Okay, so for part 3, just to refresh, we've got this thing that's terribly called test delete. This is really the Draper DEM classified into our 20-meter classes, right? We've got our green space, our binary green space that we resampled to a 5-meter cell size. We ended up with this bogus third class, remember, that is really big and I'm suspecting represents the rest of the rectangle extent here. But what we're really concerned about, and exclusively concerned about, is this green. And so green has a value of 1. We're going to add this data set to this data set, and all we really care about are all of the 1421s, 1441s, 1461s, 1481s, because those are the cells that were both in this class and green. We're not going to worry about this one at all. I can reclassify this and change this to 0 or to 2 or whatever else I feel like, but let's just stick with it. It's a little confusing because the 29 bumps 1429 up to 1449, so it gets a little confusing, but I'm literally going to disregard it anyway, and I'm only concerned in the things that end in 1, because those are going to be my true locations for green within each class. Okay, so we could try and fix this like we talked about. We could clip it, we could redo it, but I'm just going to push on and just see what happens. I'm not doing it blindly, but just thinking I'll evaluate after. So we're going to go to raster calculator, and we're going to take our green 5-meter data set, double click, and add it to our Draper DEM classified, and we're going to call it the plus or the addition version of the green space and the DEM. If you have any troubles running the raster calculator, search for, in your search for a tool called plus. It does the same thing. All of the raster calculator functions can be done as a standalone tool. You can minus, plus, times. There's funky words for a lot of them, but if you either look in the toolbox or just Google ArcGIS, how do I add 2 data sets or 2 rasters together, you'll find the answer really readily. Okay, so all that's taken care of. Go ahead and do it. And the first thing you should notice is I lost my classifications, and instead it's symbolizing it with a stretched color ramp. And don't let this freak you out or slow you down. The key would be to look in the attribute table and just see what we have to work with. So we have legitimate results here. We've got 1421. Great, that's this class that is green. 1441, that's this class that is green. 1449, that's this class that is not green, but we don't care. We're not concerned with this. We're concerned with this guy, this guy. We don't care about these. We care about this guy. So these are the cell counts that we're actually going to be looking at. One thing we can do is we can just force it to symbolize, not with a stretched color ramp, but we could either classify it or just go ahead and symbolize it with unique values. There aren't that many. Certainly ARC can handle that many colors. It doesn't need to make sense to us either. What we're looking for is just some verification that it worked. So you can see our elevation bands, our classes, and then you can see our pattern of green space within that. And so if we, let me close this guy, and, whoops, I wanted to do that. And then what am I looking for here? Our green space TIFF. So what we're looking for are these same patterns. We have the golf course stuff that's running through here, the fairways. Look for those same patterns. They're still there. These guys are the fairways, our heart shape, and also this guy. Going back to the original. So what's the moral of the story here? So the moral of the story is we've got this thing that has our green space preserved within each elevation class, our bands of elevation here. This gives you all the information that you need, our plus, to fill out the attribute table. Or sorry, you know what I mean, the table that you're supposed to submit for your submission. So what you're looking for is the cell count that's 1421. Now, how can we calculate the area that is green within this elevation class. We know that the cell size, because we just resampled it, is a 5-meter cell. So the cell area is 25 square meters, right? And we can multiply 25 square meters by 504 and get the total area that is green within the 1420 elevation class. Or a simpler way to do that is when you get your table all set up, you've got your cell counts, you can just do what's the total cell count for each elevation class, which you could also get from here, and this is where you would get it for your table that you're going to submit. So here's our Draper DEM classified table. Elevation class 1420 has 1,701 cells in it. 504 of those are green. So right now you should be able to say about a third of that smallest elevation class is green. Let's take a look at that. So here's our smallest elevation class, and what it's saying is that these teal colors should be about a third of, there should be, I don't know, 2 times more red ones than there are. Let me see, what was I going to say about that? You can see there's some funky little, these are I think those little mistakes, or these little purple guys that are hanging out here. But that's one way to evaluate yourself as well, is just to look at the proportion of the total that is green and just eyeball it and ask yourself if that seems reasonable. But that's the gist of this. This is how you're going to fill out the rest of that table and then ultimately calculate the percent total of each class that is green. Again, this is kind of a weird setup for a problem because it's a little bit arbitrary with elevation classes, but if you think about this being neighborhoods or even something like, well, voting districts doesn't make sense, although it wouldn't necessarily have to be a classified green space image either. But I would imagine this being most useful for city planners, developers, landscape architects, things like that. Alright, so zooming back out to layer. Hopefully that helps. If you have questions, definitely let me know. You'll be doing the same kind of calculation or model in part 3, dealing with habitat for snails. It's the same concept. So questions, let me know. Thanks.